Hello friends, welcome to this new video on 11th standard physics, and this is the second video on thermodynamics. In this video we are going to see the types of thermodynamic process which are very important. These are the types which we are going to study: isothermal process, isobaric process, adiabatic process, isochoric process and all this. And before that I will also teach you ideal gas equation, which is also one of the very important fundamentals to learn this process. Let's begin. So friends, let's start understanding types of thermodynamic process. For that, we'll study ideal gas equation first. Ideal gas equation. First, we should know what is gas. So gas is one of the states of matter in which the intermolecular force are somewhat less or quite less as compared to solids and liquids. And what is an ideal gas? Ideal gas is a gas where intermolecular force are assumed to be zero. So there is no force of attraction between molecules of the gas. So therefore this gas will expand in such a way that it will occupy the entire room where it is filled in. So ideal gas, intermolecular force is zero. Intermolecular force is zero. So that is very important property of ideal gas, and the equation which is followed by ideal gas is called ideal gas equation. That equation is PV equal to nRT. Let's learn this equation. All the terms of this equation we will try to understand. So friends, PV equals to nRT. What are these things? What is P? So P is the pressure of the gas. P is the pressure. V is the volume. V is the volume of the gas. Okay. N is the number of moles. Number of the moles of gas. R is the universal gas constant. Universal gas constant. And T is the absolute temperature of the gas. Absolute temperature of the gas. This is a PV equals to nRT, ideal gas equation, which relates the different properties of the gas, which relates the pressure, volume and temperature of the gas. This equation tells us how pressure, volume and temperature are interrelated. Pressure into volume is equal to number of moles into universal gas constant into temperature. We are not going to go in too much depth about this equation because this is a separate topic which is dealt in another chapter where we are going to go in much detail on this. So this was a just brief introduction about this. Now with this fundamental we will learn the different type of thermodynamic process. So friends, to learn this thermodynamic process, what we will do is we will take one example. We will take one system having a gas, which is enclosed in a cylinder. The cylinder has a piston which can move very freely like this, and we have arrangements to heat the gas. So friends, what is the system in this? The system which we are going to study is the gas which is enclosed here. This gas, we are assuming that it is an ideal gas, and remaining things are surrounding. Now first process. The first process which we are going to learn is the isothermal process. Isothermal process. Isothermal process means the process. What do you mean by process? Process means going from one state to other state, going from state 1 to state 2. Now in thermodynamics, as I told you in earlier video, how to go from one state to other state? There are two things which are possible to go from one state to other state. One thing is you can do heat transfer. The second thing what you can do to go from one state to other state is work transfer. These two things happen to make the system to go from one state to other state: heat transfer and work transfer. So how do you heat the system? By some external source you can heat the system. Okay. Now in isothermal process, the main thing is while going from state 1 to state 2, the temperature remains constant. The temperature remains constant. The temperature remains constant. Okay. So if you apply the ideal gas equation PV equals to nRT and you say that temperature remain constant, if you say like this, then what is the final result? If you say that temperature is constant and if you apply ideal gas equation on the system, if you say temperature is constant and N is also constant, number of moles, because this gas is enclosed, and R is also constant, so we can say that PV equals to what? Constant. And if you say PV equals to constant, means you can say that P1 V1 equal to P2 V2. That is the pressure of the gas in the state 1 and volume of the gas in the state 1. The multiplication of both is equal to pressure of the gas in the state 2 and volume of the gas in state 2. So this is the equation which depicts the isothermal process. Isothermal process. But it is only applicable if we are using which gas? If we are using ideal gas. Okay. So now let's do the next process, which is, see what we are doing is not the end of this processes. We are going to deal this process in too much detail in coming videos, where we are going to apply the first law of thermodynamics in each of this process. We are going to apply our first law and see what are the results if you apply on the isothermal process. But those things will be dealt in later videos. Now we are just doing some brief introduction about each process. So first we have completed isothermal process. Second, I am going to tell you about isobaric process. Isobaric process. Again, what we will do is the same system in which there is a piston and a gas, and this gas we can do the heat transfer and we can do the work transfer, and you can apply the ideal gas equation PV equal to nRT. Isobaric process means pressure remains constant. That is the basic fundamental of isobaric process, that pressure has to remain constant. Which pressure? Pressure of the gas has to remain constant. If pressure is constant, and you know that N is also constant because it's a closed system, the gas cannot escape out, R is also a constant. So what we can say that V upon T is also one constant. If you can take this T on this side, then V upon T becomes a constant. What is that constant? That constant nothing but nR by P. So if V by P is constant, we can say that when the system goes from one state to another state by using that isobaric process, then V1 upon T1 equals to V2 by T2. So this is the equation for isobaric process in which the pressure of the gas remains constant. Now let's do the third process, which is isochoric process. Isochoric process. Isochoric process. Isochoric process means the volume of the system remains constant. Volume of the system has to remain constant. If the volume of the system is to remain constant, this is the gas. And how do you ensure that the volume remains constant? You fix this. If you fix this piston here, the piston is not allowed to move. If piston is not allowed to move, even if you do the heat transfer, even if you heat the gas will try to expand. Gas tries to expand, but there is no space for the gas to expand. If there is no space for the gas to expand, the gas cannot move, and therefore the piston cannot move, and volume has to remain same. So if the initial volume is V1 and the final volume is V2, then volume V1 will be equal to V2. And if you apply the ideal gas equation PV equal to nRT, again you can say the volume is constant, N in R is constant. So P by T is nR by V, and which is a constant. Therefore we can say P1 by T1 equal to P2 by T2. And this equation depicts the isochoric process for an ideal gas. For an ideal gas. This is the equation for isochoric process. Now let's see the next one, which is the adiabatic process. What is the adiabatic process? How do you define it? The adiabatic process is such a process in which heat transfer is zero. Heat transfer to the system or by the system is zero. No heat transfer. How do you attain that? Suppose you have the same type of system, a gas enclosed in a piston, enclosed inside a piston in a cylinder. And if you insulate this gas, suppose, like you do in the thermos flask, there is an insulator which does not allow the heat to transfer from system to surrounding. Even though the gas may be at higher temperature, some gas may be having P1, V1, T1, and there may be some surrounding temperature may be less than the gas temperature, even though the heat wants to go from the gas to the surrounding, but we are not allowing the heat to transfer because we have insulated the system from the surrounding. How we have insulated? By putting suitable material which does not conduct the heat. So if you have done that, the heat transfer to the system or from the system is zero to the surrounding. There is no heat transfer between the system and surrounding. And in this way, we are doing one process which is called as adiabatic process. Okay. So in this process, suppose some other process, the gas expands, and because of this, volume of the gas change from V1 to V2, pressure may also change from P1 to P2, but the main thing is that heat transfer will be zero. Okay, so this is the adiabatic process, and later I am directly writing the equation for adiabatic process, which is PV to the power gamma is constant. What is P? P is the pressure, V is the volume, and gamma is the ratio of specific heats. Ratio of specific heat, that is Cp by Cv. Cp is the specific heat at constant pressure, specific heat of the gas at constant pressure. So I will write it here. Gamma is Cp by Cv. Cp is the specific heat at constant pressure, and Cv is the specific heat at constant volume. So that is PV to the power gamma is constant. That means we can say that P1 V1 to the power gamma equal to P2 V2 to the power gamma. That means pressure of the gas in state 1, volume of the gas in state 1 to the power gamma of the gas equal to P2 into V2 to the power gamma. That is the adiabatic process. So now the last process which we are going to deal is the polytropic process. So in the polytropic process, this is a general process wherein we can fit all other process. Polytropic process, we define it as a general process in which we can write that PV to the power n is constant, where n can have any value. N can have any value, and if you go on changing the value of n, it will define the different types of process. For example, if you put n equals to 1, then it will become PV to the power 1 equal to constant, and this depicts which process? Isothermal process. If you put the value of n as gamma, that is the ratio of specific heat, it becomes PV to the power gamma is constant, which is nothing but adiabatic process. If you put n equals to minus infinity, then this becomes, or n, if you put n equals to 0, then PV to the power 0 is constant. That means P into 1, that is P is constant, and it becomes isobaric process. So this way we go on putting the different values of n, and we go on getting the different process in the general equation of the polytropic process. So friends, this is how we define all the process, and just let me summarize all the process in a table. What we have learned now in this lecture, that we have learned different process like isobaric and isochoric and adiabatic and isothermal and polytropic, and we found the equations for each process. What is the equation for each process? For an ideal gas, isobaric process we got P equals to constant, and isochoric process we said that volume is constant, adiabatic process we said that heat transfer is 0, isothermal process we said that PV equals to constant, and polytropic process we said that PV to the power n equals to constant. So this table is the summary of all the process and gives the key thing which differentiate one process from the other process. So hope this helps in your future understanding of this subject. Till then, best of luck. Bye.